Okay, so here we're going to do a 2D relative velocity problem. And we have Raphael dressed in a Spider-Man suit to help us out. So what we're going to do is we're going to look at Raphael, and he's going to cross a river. And the river has a velocity to the left at 3 meters per second. And Raphael's boat can go 4 meters per second. That's the velocity of the boat relative to the water. That's going to always be in the direction that the boat is aimed for the velocity of the boat relative to the water. What we want to know is what's the velocity of the boat relative to the ground. So as Raphael aims straight across as he's in the water, what would that look like to someone on the ground? Well, we break out our subscripts. Velocity boat ground equals, we start with boat, end with ground, and we have water to link us in between. So we put the values in here. The velocity of boat water is 4. The velocity of the water to ground is 3. So we do 4 plus 3. But in this case, it's not going to equal 7. It's not going to equal 7 because now we're adding with vectors. So we have to make sure that we include the direction, and we do this in a tip-to-tail method. So we take our vectors. We have 4 plus 3. And the velocity of the boat ground is going to be the hypotenuse of that. So we can do the Pythagorean theorem, and we find out that the resultant is going to be 5 meters per second. So if you're on the ground, you would actually see the boat moving at 5 meters per second. But it's not going straight across, it's going at an angle. So let's find out what that angle is. The tangent of the angle is opposite over adjacent, which is y over x. And I like to be consistent with that. And if we're doing that, then we're looking at this angle right here, because the y is the opposite and the x is the adjacent. So we do the inverse tangent of both sides, so that the left side leaves us with just theta, and the right-hand side leaves us with the inverse tangent of y, which is 4 over x3. And we find out that we get 53.1 degrees. But we need to make sure we get them at what direction that is. So if we look at this, we're down below the negative x-axis. So we want to say that to get them thinking in the right direction, that down and to the left. Or you could say that it's 53.1 degrees south of west.